question 10. Okay, this one is from glider. I've also given you guys the formula earlier. All right, so now I gave you guys three formulas under when two particles are connected, as two particles are suspended and they're connected over a pulley by a string. Their common solution is what? Formula calculated for common solution is m2 minus m1 g divided by m1 plus m2. Right? Yes. Now the other one that I gave you guys, that when an object is on a pulley, is on an inclined plane and is connected to another object that is suspended, the common solution would be m2g minus m1g sin theta over m1 plus m2. Okay. Now in an X-track glider, one of the mass is resting on a plane on a horizontal surface, the other one is suspended. In this type of to calculate the common solution is m2 over what? m1 plus m2 then times g. Right? Yes. now let's continue. I want to tell you guys something. Okay, I also told you guys that to calculate for the force acting on this system, and the force is usually equals to 2 of the tension. Then to calculate for the force acting on this system, the force is usually equals to what? Root 2 of the tension. Okay, do root 2 then times the tension, right? Yes. Now look at this question. It said a 2 kg glider. Okay, so this question comes out from this place. A 2 kg glider. 2 kg glider is connected to a 0.5. I'm coming. Is connected to a 0.5 kg mass with the aid of a string over a frictionless pulley. What is the force on the pulley? Okay, now tell us calculate for the force of this system. Right? Yes. Now to know the force, we need to know the tension first. Right? And to get the tension is very easy. Okay. So the tension is usually out on the string. Right? This is a string. Tension is usually out on the string. Right? Yes. Now how do we get the tension? Yeah, we need to get the tension first. Right? Yes. How do we get the tension? Yeah, tension is very easy. Okay. Now let's look for a total force acting here and total force acting here. How many forces is acting here? How many forces is acting here? It's only one, which is only tension, right? So in this place, total force acting there is what? It's just one, which is the tension. What about here? Total how many forces acting here is 2. The tension as well as what? The weight, right? So the total force acting here is what? Is the tension minus what? The weight is going down, the tension is going up. So tension minus what? The weight, right? Minus the weight. Okay? Yes. So don't forget that total force is equals to what? Total force m1a, because we are dealing with this mass. Since we are dealing with this other mass, to be what? Total force here will be what? Will be m2g. m2a, right? Yes. Now if you look at this, if you look at this place, we are not done yet. I'll tell you guys something. If you look at this place, now the direction of motion of this whole system is always like this. The direction of motion is like this, right? To go like this, then come like this. Right? Now remember, tell you guys that when an object is going downward, when an object is going downward, remember, yes, vector, right? This is positive y, this is negative y, right? Yes. So going downward will be positive, will be negative, right? Yes, negative. Depending on the coordinates we are using already. Normally, depending on the coordinates we are using. Okay. So negative. We are using this first coordinate. Going downwards is negative, right? Yes. So if you look at it, this mass this mass will move with acceleration going downward, right? While this one will move with acceleration going like this, right? Yes, going to the positive x. Now this mass will move downward, right? With an acceleration going down, going to negative y. Therefore, the acceleration here is negative. The acceleration here is positive. I don't even understand. Look at it. This is the mass. This mass will move towards this direction. This other one will move towards like this, right? This is the direction of the motion. This one will drag this one with it, alongside with it. So this second mass, M2, we move it as the acceleration is usually adds downward, right? Therefore, the acceleration is negative. What about this other one? This one is moving towards the positive x-axis, right? Therefore, the acceleration is positive. So let me tell you that the acceleration here in M1, atom M1, is positive, While acceleration acting on M2 is what? Is negative. So I'll put minus here. Okay, because M2 times minus A will give us minus M2A. Look at it. M2 times minus A will give us what? Minus M2A, right? Yes. So we are not done yet. So we are not done. We are looking, we want to look for the tension. Once you get the tension, we take the root 2 of that tension, get the answer. Okay, so if you look at it, tension is equal to M1A, or tension, or remember here is weight. So the weight of this one is M2G, right? So if this one comes over here, tension now be, if this one come over here, turn to plus, now be M2G minus M2A. So the tension acting on this one is either this. No, there's no that that tension is either M1A or M2G minus M2A. We can use any one. The tension in this system, acting the tension here and here, they are equal. Okay, so we can use any of them. I don't understand. So let's just use this one. Let's just use this one. Okay, so let's just use this one. So the tension is what? Tension is equal to M1A. We can use that one though. M2G minus M2A. We can use it, we still get the same answer. So since this is the Rhema, so for the sake of time and for the sake of other question, let's just use this one. Tension is equal to M1A. Right? So tension will be equal to what? Now what is M1? M1 is what? Is 2. Right? And times what is the acceleration? I will to calculate the acceleration. We need to use that formula. A is equals to M2G over M1 plus M2. Remember, this is the formula to calculate for common acceleration in an electric glider, right? So let's continue. M2 is what? In the question, M2 is 0.5, right? 0.5 then times G, we all know G to be 10. Then M1 is 2. M2, 0.5. So 0.5 times 10 will give us 5. Then 2 plus 0.5 give us 2.5, right? So 5 divided 2.5. 5 divided 2.5 is 1.78. Okay, so therefore the acceleration is what? Is 1.7. The acceleration is what? Acceleration is 1.78, right? Yes. So therefore, let's take it back now. We have gotten our acceleration to be what? To 1.78, right? So let's put here 1.78. So 2 times 1.78. 2 times 1.78. Okay, 2 times 1.78 is what? 3.56. Okay, 3.56. Therefore, the tension is what? Tension is equal to what? 3.56, right? Yes. Now, what are we looking for? Let's say, what is the force on the pulley? So, I told you guys, in order to get the force, we need to know the tension. So, we look at the tension. Tension is equal to M1A or M2G minus M2A, right? Yes. Now, we use this one because we're faster. We didn't know our acceleration, common acceleration. So we use formula to get our acceleration, multiply it by M1, got our tension to be 3.56, right? Yes, 3.56. Now we put it here. Tension is what? 3.56, right? So let's do it. Root 2 times 3.56. So let's do it. Root 2 then times 3.56 is what? Is 5. Okay, is 5, okay, is 5.034. Okay. So for this case, the closest, I don't think the closest. I think let me do it again. I'm coming. So 2 times. Let me do it again, okay? So let me be fast this time. Because I know that one of the answers is correct here. Okay, so let's do it again. So let me be fast this time. So the solution is I think we should use, okay. Let me see what am I going to do now. Okay. All right. So let's do it again. Let me be fast. Let me call acceleration. All right. So we know that in a electric glider, to look at the acceleration is M2 over M1 plus M2 times G. So our M2 is what? Our M2 is 0.5. G is what? 10. Then M1 is 2 plus M2 is 0.5, right? M2 0.5, right? So let's do it. Let me fast this time. Okay, so 0.5 times 10, then divided by 2 plus 0.5. So we get 2. Our acceleration is 2. Okay, so the acceleration is 2. Okay, so A is 2. All All right. A is 2. Remember, tension is equals to M1A, or tension is equals to M2G, or M2 minus M2A. I said you can use any of them. So let's use one of them, okay? So acceleration is 2. Okay. I think where we didn't get our performance, I didn't approximate the acceleration. So A is 2, right? Now, so tension is equals to M1A. So M1 is what? Is 2. A is 2. So 2 times 2 is 4. So tension is 4, right? So now let's continue. Remember, to look for the force in a extra ladder, force equals to root 2 tension. So our tension is what? Our tension is 4, right? So root 2 times 4 give us what? So let's do it. So root 2, then times 4. I'm coming. Root 2 times 4 is 5.656. Okay, so our force is what? Is 5.656. If you look at the option, you see 5.65 here, you see 5.66. So the best we choose C, because we approximate this to what? To 5.66. Okay, yeah, so the best one is 5.66. Okay, we know that this one is still correct, but if we approximate this value, because there's a larger tendency that this is 5.66. So the answer is 5.66, which is C. Now let's do question 11. Okay, so please take note of all this. All right, it's very important. Now let's do the next question. Question 11. They said find the proper banking angle. This is under circular motion. Okay, let me just be spelling out things, important things for you guys. Let me give guys important things to know. Okay, so to look for banking angle, this is Rhema, so I'm not going to derive anything. I'll just give you guys the formula. Okay, for banking angle, look at the formula for banking angle. Banking angle is equals to what? Is usually equals to U equals to tan theta. All right, yeah. This is question of friction. Okay, so question of friction equals to what? Tan theta, right? Yeah. So if you want to look for this, is the banking angle. So if you want to look for backing angle will be shift inverse, the inverse of U, right? Yes. Now apart from that one, take note that U, this is very important. Take note that U, equation of friction is equals to V square over rho G. Okay, yes. So just in case, in some question, they will not give you U directly. So you need to look for U by using V square over rho G, right? Yes. Now let's look at the question. Say find the banking angle for a car making a ton of radius. Look at it. I'm just saying it just now. In this question, they didn't give us U. They say look for what? Banking angle. So it's very easy. So let's look for U first. U is what? U is equals to V square is what? Let's look at the velocity. Let's continue. Find a proper banking angle for a car making a turn of radius 100 meter. So the radius is 100. Remember, G is always 10 or 9.8. Then V, let's continue. At the speed of 16 meter per second. So V is what? 16. Remember, all square, right? Yes. So let's do everything. Let's get our U first. Okay, so U will be what? So U will be 16 square. Okay, so bracket open 16, bracket close, all square divided by 100 times 10 is 1000, right? So U is what? 0.256, right? So U is what? 0.256, right? Now put it here. Backing angle is equal to inverse tan of what? 0.256. Just go to your calculator, press shift and tan, then you do it. So shift tan 0.256. Our answer is 14. Okay, yeah, 14. Once I've got 14, here is 14.35. So the answer here is B. Okay, yes. Now let me approximate. Let me approximate to 0. Remember, here is 0.256. So let me approximate to 0.3. Okay, let me approximate to 0.3. Let me see. So shift tan inverse tan 0.3. So we got, okay, I got 16.699. No. Okay, so let's just use the normal value 0.25, or approximate that 5 to 6, 0.26. So yeah, I think it's closer, 14.57. So the answer is 14.57. Here is 14 approximately 14.6. So the answer is B. Okay, now let's move to the next series of question. All right, so let's continue with this next series of question. Okay, so Now let's start with this question. They say if the force of attraction between two masses separated by a distance 2d is F, what will be the new force if the distance is twice the initial distance? Okay, so this question is coming down from Newton universal law of gravitation, right? Yes, Newton universal law of gravitation, which state that the force of attraction between between two objects is directly proportional to the product of their mass, right? Yes, directly proportional to the product of their mass, and inversely proportional to the square of their distance apart, right? Yes. Okay, let's say this one's on M1, M2, right? Yes, I said now they say if the force of attraction between two masses separated by a distance is F, okay? So let's say F1, for example, is F, okay? If the force of attraction between two masses separated by distance, 2d is F, okay? So the distance, okay, let me just illustrate it now. Coming. Now, okay, let's say two bodies, right? Two masses, M1 and M2, right? So the force of attraction between these two masses is F, right? Then the distance between these two is 2d. So say d1 is equal to 2d, right? They said what will be the new force? We're looking for F2. We don't know. Okay, what will be the new force? What will be the new force if the distance is twice the initial? Normally, this was the initial distance. The initial distance was 2d. Right now, if the distance is now two times, twice the initial distance, right? So that is d2 what? With twice of this, which is two times of this one will be, should not be 4d, right? Yes. So we have arranged now. So our F1 is F, our D1 is 2D, our D2 is 4D, then we are looking for our F2, right? Yeah, so what will be the new force, which is F2. Now remember that according to Newton's laws of universal gravitation, which said that the product of which that the force of attraction between two objects is directly proportional to the product of their masses and inversely proportional to the square of their distance apart, right? Yes, remember the force is directly proportional becoming directly proportional to what? To the product of their masses, right? Yes, and this is directly proportional. This is symbol for directly proportional. While this is one inversely proportional, right? So the for Newton's law of gravitation, it said that the force of attraction between two masses is directly proportional to the product of their mass and inversely proportional to what? To the square of their distance apart. So this the force is inversely proportional to the square of their distance apart, right? Yes. So we are looking for what? F2, right? Yes. Now, let's say, for example, maybe we all know the formula now. We all know the formula. F is equals to, we all know the formula G M1 M2, right? All over D square, right? Yes. Since in this type of question we are relating two quantity, force and distance, we will make the rest of them constant. If you look at the question, we are looking. We are really relating to quantity, distance and force. This distance and force, right? They said, well, if the force of attraction between the two masses separated by distance, if F1 is F, then distance D1 2D, then what will be the new force F2, which you don't know, if distance is twice the initial distance? So we'll make everything here constant, make them 1 or constant, okay? We'll make them K, make everything K. So if we cross multiply, we have what? We have K is equals to what? F D square, right? Yes. Since K is equals to F D square, so wherever we see K, we put what? F D square, right? So now something like this, F D square 1, F1 D square 1, then equals to F2 D2 square, D square 2. So let me arrange it again. So F1 D1 square is equals to F2 D2 square. Finish. We are looking for what? We are looking for F2, right? So our F1 is what? Is F. Then our D1 is 2D. 2D. Remember, it's all is square, right? So since it's square, square of 2 is 4. Then square of D will be D square. So everything here will be what? Everything here will be before d square, right? Then is equals to, we know our F2 no, so we put F2 like that. That is what we're looking for. Then what about our D2? D2 is what? D2 is 4D, right? D2 is for 4D. So remember, this D2 is R square, right? Yeah, it's R square, right? So we know that D2 is what? 4D, and it's what? It's squared. So the square of 4 is what? 16. And the square of D is what? D square, right? So 16D square, right? Yes. So F times 4D square will give us okay, let me just continue. Okay, so F times 4D square will give us okay, let me arrange it. 4D square F, right? Or let me just continue like this. Okay, we are looking for what? We are looking for F2, right? So what I'm going to do, divide both sides by what? We are looking for F2. We'll divide both sides by, we want to make F2 stand alone. Divide both sides by 16D square, right? So 16D square, 16D, 16D square. So this one will cancel this, right? So therefore, F2 equals to what? F2 equals to F times 4D square over what? 16D square, right? Yeah, so let me clean all these things. Okay, so F2 equals to what? 4 times 4D square. I mean, F times 4D square divided by 16D square, right? Yeah, so this D square will cancel this D square, right? 4 here is 1. 4 into 16 is what? Is 4, right? So it's 4. Therefore, F times 1 will give us F. Then divide by what? 4. Therefore, our F2 is what? Is F over 4. So where's our answer here? Our answer is B. Okay, yeah, so F over 4. So that's our F2 is what? F over 4. So that's the answer B. Okay, now let's go to question 16. All right, so question 16. A block on an inclined surface, on an inclined plane, a block on an inclined plane is kept stationary by how many forces? Now, I've explained this in our previous class under friction. Okay, now let's say this is a block in an inclined plane. A block in an inclined plane is acted upon by 3 forces. One of the force is the normal reactional force. The other one is the weight force. Yes, normal reactional force, weight force, and which one again? They are theory. Okay, reactional force, normal. Then I think frictional force also, frictional force. So just thinking that it's theory. Okay, there are 3 forces. A block on a rough inclined plane is kept stationary by how many force? It's kept stationary, yes, by 3 force. The reactional force, the weight, then normally the block has the tendency of falling this towards the side, right? Therefore, there's a static friction that's there's friction as well, static friction. So it's 3 force, right? Yes, to prevent you keep the block from not moving. So it's 3 force. So the answer is B. Then move to the next question. Question 15. Okay, so they said the force responsible for holding atoms and molecules together is called what? Is called electromagnetic force. Okay, yes. Then the force that holds the nucleus together is strong force. Okay, yes, or nuclear force. So they said the force responsible for holding atoms and molecules is electromagnetic force. Okay, very important. Then move to the next question. Question 14. Okay, so question 14, I said, 2 particles of mass 7 kg and 9 kg are connected by. So this is the 2. Okay, let's say this is the pulley. So these are 2 particles. Okay, so 2 particles of mass 7 kg. So M1 this is M1, this is M2. So M1 is what? M1 is 7 kg. Then M2 is what? M2 is 9 kg. Okay, so are connected by a light string passing over a pulley, passing over a smooth piece pulley. Find the force on a pulley. I've told you guys earlier this one earlier. I told you guys that when in an electric glider, the force is usually equals to what? Root 2 tension. Then but when it is in this format, when the same 2 masses are connected by a string over a pulley, they are suspended. The force is what? usually what 2 of the tension only. Okay. in an natural glider is root 2 tension, but here is what is 2 tension. Okay, so in the natural glider is what root 2 tension, then why here is what 2 of the tension. Okay, 2 times tension. So what I'm going to do, we are looking for what the force in the system, right? Yes, so we need to know the tension first, right? Yes, we need to know the tension. How are we going to know the tension? It's very easy. Okay, now let me show you how. Now now this system, the direction of motion in this system is like this. Is like this. Okay, like this. Okay, yes. So that will tell you that this M1 is moving towards this side. Then M2 it was because the M2 is heavier than M1. So it drags M1 alongside it. Okay, so the M2 is coming down like this, so M1 will follow, right? So the direction of motion of M2 is what? Downward, right? Yes. So the acceleration is downward for M2. Then for M1, the acceleration is upward, right? Yes. So now remember, since it's a string, there's always a tension at. Since it's string, tension always acts on string, right? Yes. So the tension at here. Now, apart from that one, since there are some spring there, their weights go down, right? W1, their weights go down, right? W2, right? Yes. So how many forces acting on M1? It's 2 force. The tension and what? The weight. So total force acting on M1 is equal to what? The tension minus the weight. Then what about M2? How many forces acting on M2? It's still 2. Tension and the weight. So total force acting on M2 is equal to the tension minus for the weight, right? Yes. So now what is the formula for total force? Force is what? MA, right? Yes, since we are dealing with M1, here will be what? M1A, right? Then because of tension minus weight is what? We all know that weight is equal to mg, right? Since we are dealing with W1, so we are dealing with M1 with what? M1g, right? So weight is what? M1g, right? Same goes for here. Total force is what? M2A, right? Tension, then weight is what? M2g. So we are dealing with mass 2, right? Yes, but we are not done yet. Now the acceleration here, look at it. This acceleration of this M1 is going upward, right? Positive. So the acceleration is positive, going positive y direction up. Yeah. Then where is the direction of motion of M2? The acceleration is going downward, right? M2 is going downward, right? So the acceleration is what? The acceleration is negative, right? So A is negative. So this acceleration is negative, acting on M2. So since it's negative, minus A times M2 times minus A will give us what? Minus M2A, right? Yes. So therefore, here will be what? Minus M2A, right? Yes. What are we looking for? We have to look for tension first, right? Yes, we want to look for tension, right? Yes, once we know the tension, multiply it by 2, get our total force, right? So to look for tension, this one comes over here, right? So now be tension now equals to M1A. If this one cross towards the turn plus, right? M1A plus M1G, right? Yes. So this is tension, right? This one can, if this one cross towards the side, it turns plus, right? So tension now equals to M2G then minus what? M2A. So we can use any of the tension. That is just, we can use any of the tension. Yes, if we use this one, we still get the same answer, right? Yes. Now, since we can use any of the tension, what else do we not have here? We don't know the acceleration. We know mass one. We know the masses. We know G is 10. We know the masses, right? Do we know A? No. So let's look for A first. Now, how do we look for A? A is very easy. I've given you guys that one to look for the common acceleration in a pulley. When two pulleys are connected together, when two mass are connected together by a string, blah blah blah. Yeah, when they are connected by a string, the common acceleration is what? A is because I've given you guys m2 minus m1 divided by m1 plus m2, then multiplied by g, right? Yes. So let's look for the acceleration first. Okay. Yes, let's look for the acceleration first. Once we get our acceleration, we put our acceleration here, we get our tension, then multiplied by 2. So where is our acceleration? So where is our M1? M2 is what? M2 is 9. Okay. Now M1 is 7. Okay. G is what? Okay. Let's use 9.8. Okay. Then divided by M1 is 7. M2 is 9. Okay. So let's do it. So let's do it. Okay. Let's do everything. Okay. Let me just be fast. So bracket open 9 minus 7. Bracket close times 9.8 divided by we divide by 7.7 plus 9. So the acceleration is 1.225. So A is what? A is 1.225. A is equals to 1.225. So this is their common acceleration, right? Yes. Now we have this. We can use any of this one. We can use this one. We can use this one. We can use this one. So let's just use this. T is equals to M1A plus M1G, right? So let's use this. So where's our one to potential? Where's our M1? M1 is what? 7, right? Then A is what? 1.225. Bracket close, then plus M1 is still 7, right? Then bracket open. G is what? G is 9.8. So let's do everything. If we do everything, we get our tension multiplied by 2. We get total force. So it's very easy. So bracket open. Bracket, okay, 7 bracket open. 1.225. I'm coming. 1.225 bracket close. Then plus 7 bracket open. 9.8 bracket close. So the tension is 77.175. So tension is what? 77.175, right? Yes. What are we looking for? Looking for what? The total force, right? The total force is because of what? 2 of the tension, right? So 2 times tension is what? 77.175, right? So let's do it. So 2 times 77.175, and one side is 154.35. So the total force is what? The net force is 154.35 Newton. So let's look on our action. So this would be the answer, 154.3. So Newton. So that is C. So that is very easy, okay? Then let's go to the next question. Question 13. Okay, so this is the next question. Now, they say calculate the altitude of a communication satellite. Okay, coming. They say calculate the altitude. Calculate the altitude of a communication satellite in a synchronous orbit. Now, in our previous class, under gravitation, I told you guys what is synchronous orbit. Okay, synchronous orbit. This is the type of orbit that has the same period as the Earth. Yes, type of orbit where the time of now normally the Earth revolve around its axis every 20, the time it will revolve around its axis 24 hours, right? Yeah, in a day, 24 hours, right? Yes. So a satellite so I tell you that the period of the Earth is 24, right? Like 24 hours, right? The Earth revolve around its axis 24 hours, right? Yes. So the period, which is time at which the Earth revolve around its axis 24 hours, right? Yes. Now a synchronous orbit. In a synchronous orbit, a synchronous orbit, this is a type of orbit carried out by a satellite that also revolve the orbital period of that satellite is still what? It's still 24 hours. Okay, yes, still 24 hours. Okay, yes, those satellites, if you view them from the Earth, you find out that they are stationary, but they are not stationary because the reason why you say you think that they are stationary because they have the same period. The period at which they revolve, the rate is the same as the period at which the Earth revolve around its axis, right? Yes, so that's why you find that they are stationary, but they are not stationary. So a synchronous orbit is also known as a stationary orbit. Okay, it's not as if the satellite are actually stationary. No, it's because they are revolving at the same period as the Earth is revolving around its axis. Okay, so it just in synchronous orbit, the important thing to know in a synchronous orbit is that the period of the orbit is what? 24 hours. Okay, so let's say the switch calculate for what? The altitude of a communication satellite. Okay, in a synchronous orbit. Okay, this is the mass of the Earth, this is the radius of the Earth, then this is G. So how I'm going to do this is very easy. Okay, so at first, let me give you guys a formula to calculate for period. Okay, we need to know the period first. Okay, we are looking for altitude, right? Yes. So there's not much time. Would have teach you guys how to derive it, but there's not much time. Let me just give you guys the formula to calculate for period. I think it's T. Okay, T is equals to. I think I should derive it. Then, but I'll be fast. Okay, F equals to F. MV square over arrow, then G MM over arrow square. This one cancel this, then this cancel this. So GM over arrow is equal to V square. Then we know V is 2 pi. Yeah, V is 2 pi T. Then all square. then okay, gm over r is equals to 4 pi square over t square. Okay, forget r as your r square. Okay, r square. Okay, so okay, let me start again. Okay, so G, so I'll cancel this. So left with gm over r is equals to velocity, right? Velocity itself is w. Let me just be fast. So velocity is 2 pi r over t. Since it's called all squared, then we now have something like this: gm over r is equals to 4 pi square r square divided by t square. Okay, so this, all right, divided by t square. All right, so okay, yes. So let's continue. Now we want to make t stand alone. So cross multiply c square gm is equals to 4 pi square r cube. R times r square gives us r cube. Then we'll make t stand alone by dividing both sides by gm. Right? So gm. Okay, so the formula for period is t is equals to 2 pi root r cube all over gm. Okay, so this is the formula calculate for period of a orbital period. I've derived this now. If you go to our class, our previous class in gravitation, under the topic gravitation, you will see how I derive it. Okay, so this is the formula. Now, arrow, which is known as arrow, is the distance. I'm coming. So arrow is distance. Let's say this is satellite. So arrow is distance from the center of the earth to the satellite. While from here to here is the radius of the earth. From the surface of the earth to the satellite is known as altitude. Okay, so arrow is equals to what? Radius of the earth plus what? Altitude. Right? Now they're asking us to look for what? They say calculate the altitude. They're asking us to look for h. So remember, arrow is what? Arrow e plus h. So whenever we see arrow, I put what? Remember, arrow has cube. Whenever I see arrow, I put what? Bracket open, arrow e plus h, all cube, right? Yes. So we're looking for h. So what are we going to do? We're looking for h. What I'm going to do? We're looking for h. H is altitude, right? I've explained that earlier. So we take the square of both sides. The square of both sides. This square will cancel this square root. Okay. So square of t will give us t square. Then square of 2 pi is 4 pi square, right? Square of 2 pi is 4 pi square. Then this square will cancel this. We'll now be left with something like this. Bracket open, arrow e plus h, all cube divided by what? Gm. Right? Yes. So we're looking for h. Want to make h stand alone, cross multiply. So now be t square multiplied by gm is equals to 4 pi square arrow e plus h cube. Right? I mean plus h all cube, right? Now, I want to make it stand alone, so that beside by 4 pi square. 4 pi square. This one will cancel this, right? Then what next? We arrive with something like this. Okay, so we arrive with something like this. Arrow e plus h all cube is equals to t square gm over gme over 4 pi square. Okay, so what I'm going to do? Want to make this guy stand alone, right? So take the cube root of both sides. Cube root of both sides. Cube root of both sides. This cube will cancel cube root, right? So we'll be left with what? I'm coming. So we're left with arrow. We're left with arrow e plus h is equals to cube root of t square gme all over 4 pi square. Okay. Since we are looking for h, right? We're looking for h altitude. So this one will come to the other side. Because this one is plus arrow e, right? Radius of the earth. So it has an invisible plus here. So if it cross the other side, turn minus, right? So if it cross, now be what? Minus arrow e, right? Yes. So we're looking for what? We're looking for altitude, right? Yes. So usually if you are using castle calculator, it's very easy. Okay. So remember, it's a synchronous orbit, right? A synchronous orbit, the period of the orbit is what? 24 hours. Okay. So let's continue. Now let's do this. We also do everything. Let's arrange it. So h is equals to cube root. Cube root. Okay. Now what is the period? What is time? Since the synchronous orbit period is what, 24. So time is 24, right? So 24 all square, right? Then times G is what? G is what? We all know G is 6.67 times 10 is what? Minus 11, right? Then times M. Okay, I think I should use here. I think I should use here. All right, so let me use here because of space. So H is equals to the cube root of T, and T is what, 24 hours, right? 24 squared then times G is what, 6.67 times 10 to the minus 11. Then ME, mass of the earth is 5.98 times 10 to the 24. So that is ME. Okay. Then I know sorry, we all know that one. Then you divide by what? Divide by 4 pi square, right? So pi is what? Pi is 3.142, right? All square. So this is it. So if you do everything in a calculator, this radius of the earth, right? Radius of the earth is what? Is 6.4 times 10 to what? 6. So if you do everything in your calculator, we just get our answer, okay, straight ahead. Okay, so I'm going to do this. Now to tell you guys something. There is no cube root in calculator. You cannot press cube root in a calculator. Okay, so what are you going to do to get cube root? What are you going to do? Just go to your calculator. Just go to your calculator in order to take the cube the cube root of something. Let's say I want to take the cube root of A. If there's no cube root in calculator, so what are you going to do? Just press the value there. Please to take the one third of the like one third of the this thing give you the cube root. Okay. Yes. So let's say I'm going to take the cube root of 3. Take cube root of 3 is the same as 3 raised to power what, one third. Okay, yes. So that's what I'm going to do. I want to take the cube root of this place. So do everything like this. In your calculator, I'm coming. H equals to, okay, do everything like this. Bracket. Take everything in bracket form. Then raise the power to what? Everything of everything to one third. Okay, yes. So that's how I take the cube root. So one third, then minus this thing. So let's just do it together. So let me show you. So at first, bring out brackets. Bring out bracket, then break it into fraction mode in your calculator. Then let's continue. Bracket open 24 hours, 24 bracket close all square, then times 6.67 times 10 raised to power minus 11. Then we can come minus 11. Then times 5.98 times 10 raised to power 24. Then divide by what? Divide by 4 times bracket open 3.142 bracket close all square, right? Then we go to the ending, close bracket, then raise to the power of what? Raise to the power, then fraction mode, raise to the power one third, right? One third. Then we go continue. That's why I love calculator. Okay, equals to what? Equals to, I've gotten the value for this, right? I've gotten the value of this. Then let me minus, okay, minus 6.4 times 10 raised to power 6. Okay, now there's still one thing. You are good to go. You are correct. So let's continue. Times 10 raised to power 6. So the answer is, I think, okay. Let me see. What did we do wrong again? No, good. Let me see. 4 points. All right. Wait. 24. Okay. So I think got the correct answer. Okay, because why? Because this is our 24. Is in we use hour instead of seconds. Okay, so convert it to seconds. How are we going to do that? Remember, to convert from to hour to seconds, multiply by what? 3,600. Right? So if you multiply 24 times 3,600, 24 times 3,600 will give us 86,400. So everything here is what? The time is 86,400, right? So I go here, do something like this. Bracket open 86,400 all square, right? Yes, now let's do it again. Alright, let's do it again. So at first, open bracket, then divide it into form, then into fraction, right? Bracket open 86,400, bracket close all square, then times 6.67 times 10 raised to the power of minus 11. Then then times 5.98 times 10 raised to the power of 24, then divided by 4 times bracket open 3.142 bracket close all squared, right? Squared, then close, go to the ending, then close bracket, then raised to power, go to your calculator, do raised to power, then since it's 1/3, do raised to power, then do raised to power, then do press that in your calculator, press calculator that look like this. That is fraction mode, right? In some cases, calculator is S over Y. So do raised to power. Once you press raised to the power, then press this thing that puts it in fraction mode, right? So press it, then 1/3, right? So when I do everything, I got something, I got my answer. Then let's minus this, right? So minus 6, okay? So minus 6.4 times 10 raised to power 6. So our answer will be, yes, our answer will be, our answer is, okay, very long answer. So our answer is, which is, the altitude is 358,46822.501 meter. Now, if you look at our option is what? Is in kilometer, right? So to come out from meter to kilometer, divide by what? 1,000. So let me divide by 1,000 to put it in kilometer. So divide by 1,000. Divide by 1,000, you get, what? We get 35,846.8. So yes, so if we make it to be in this form, 1, 2, 3, 4, so answer will be 3.58 times 10 raised to power 4 kilometer. Okay, yes, so the closest here is A, so the answer is A. Okay, yes, so the answer is A. Wow, man. Okay, so let's continue with the last part. Oh my god. All right, the last part. Okay, so last one, they said the stationary satellite is orbiting the Earth at a height of 6 arrow. So at the height of 6 arrow above the Earth's surface. Okay, so let's say this is the Earth's surface. This center of the Earth, and this is the Earth's surface. So they said the stationary satellite is orbiting the Earth at a height of 6 arrow above the Earth's surface. So let's say this is satellite. So the height above the Earth's surface is what? Is 6 arrow, right? Yes, above the Earth's surface of the Earth. Arrow being the radius of the Earth. So arrow is not the radius of the Earth, right? Yes. They said, okay, the time period of another satellite at a height of, now another satellite, okay, another satellite again. Okay, the time period of another satellite at a height of 2.5 arrow from the center of the Earth is, okay, so this, okay, from center of the Earth. Okay, so now asking us to calculate for the, look at the time period of another satellite. Okay, so it says a stationary satellite. Remember, a stationary satellite. And remember, to you guys, stationary satellite or is a satellite that undergoes synchronous orbit, right? So the period for a stationary is 24 hours, right? Yeah, so the stationary satellite is orbiting the Earth at a height of, so this is the stationary satellite, right? The height of above the surface is 6 arrow, right? So it's orbiting, the period is of this stationary satellite is 24 hours, right? Yes. So above the surface of the Earth, arrow being the radius of the Earth, the time period of another satellite. So we're looking for this satellite in the time. We don't know. Okay. So which formula are we going to use? All right. So this is from Kepler's third law. We said that T. Let me just give you T1 square divide T2 square is equals to arrow and 1 cube divide arrow 2 cube. Okay, yes. Okay, so our T1 is what? 24 hours. Don't worry about our arrow 1. Our arrow 1 will be what? Our arrow 1, which is this, Our arrow one will be what? Is distance from here to here, right? So our arrow one will be what? Will be arrow, this arrow plus this arrow, which should be equals to what? 7 arrow, right? So our arrow one is what? 7 arrow. Okay. Then what about our T2? We don't know. That's what we're looking for. Then our arrow 2 is what? Our arrow 2 will be what? Will be from from this place to this place, right? From this one. Okay, let me break it down. This arrow, small letter arrow 1, and hence small letter arrow 2. Okay, so our arrow, so arrow 1. Then our arrow 2 is what? Our arrow 2. So our arrow 2 is what? Is big arrow plus 2.5 arrow, right? So it should be what? 3.5 arrow. So our arrow 2 is 3.5 arrow. Then um arrow 2 is 2.5 arrow. Arrow 1 is 7 arrow, right? Yes, T1 is 24 hours. So we are looking for what? We are looking for T2. So what are we going to do? It's very easy. Come here. We put it in place, we put the T1 is what? T1 is 24 hours, right? 24, then all square divided by T2, we don't know, right? So all square. Then arrow 1 is what? 7 arrow cube. Arrow 2 is 3.5 arrow cube, right? Yes, so what I'm going to do next? To cross multiply, right? So cross multiply. So it will be what? It will be bracket 24 square times bracket open 3.5 arrow all cube. Then I'm coming is equals to 7 arrow cube times T2, right? Times T2, right? So we're looking for T2, divide both sides by what? By 7 arrow cube, right? So 7 arrow cube. Okay, so T2 is what? T square rather, T2 square is equals to what? Is equals to T2 square is equals to this. So I'm looking for T. So we take the square root of both sides, right? So let me change the marker. Take the square root of both sides, right? We are looking for T2. We are looking for T2, right? Yes, but T2 has square, right? So take the square root of both sides. So this square comes the square root, right? So go to your calculator. Let's do this in your calculator. We get our answer. So let's do it. Bracket open. Square root then bracket open 24 bracket close square times bracket open 3.5 bracket close cube divided by 7 divided by bracket open 7 bracket close cube. So our answer is 6 root 2 hours. So the answer is A, 6 root 2 hours. Okay. Yes, 6 root 2 hours. So don't forget to like, subscribe, and all. Okay. So come to the end of this video. Okay, come to the end of this video here.